All right, so good afternoon, everybody. Welcome to class. So we gonna continue on the material that you might I don't think you're gonna see it on the test. It won't be on the test, but these are also some very important sections. So today we're gonna see, for instance, how to transform a graph, how to transform a certain graph. There will be no calculation, almost none, right? So it might be, a little bit boring because there will be no calculation, but it's okay. All right.
Professor, before we start, I have a question.
Yeah, go ahead.
Sometimes when I try to log on and view my textbook to try and actually do practice problems and stuff like that, it keeps saying that you disable the textbook so that we're forced to do the knowledge check before it's activated.
Oh,
Is
hold
that
on. Okay, that on Alex.
yeah?
Okay, that's a good question. Let me double check that if it is on me or something I should do. So let me see.
Yeah, because I'll have to log in and then I'll try to log out and come back in 5 times and it keeps saying that, and then until I do the actual knowledge check, then it won't let me access my textbook.
Yeah, I mean, so have you done the knowledge check at once? Have
Yeah,
you done it?
I did it, but I wanted to access my textbook. So,
Okay, let me see. So class summary. All right.
after I finished it, yeah, it let me access it, but I wish it wouldn't deactivate it before I do it, so that way I could do it and also possibly do the knowledge check some other time.
Okay, hold on. As a download. So okay. I mean, the book I see here, the textbook here is paired right here with the textbook. This is paired with the textbook I see here at my end. So now for the knowledge check, incoming students, select an option for the students moving between Alex classes, etc. So don't carry over the progress. All right. Okay, so accessibility, stuff like that. So that one, okay, so you see gradebook enabled, stuff like that. So I don't think nothing here, I don't see nothing at my end. I don't see nothing that prevent students. So now for the knowledge check now, what I'm saying, what I know is for the knowledge check, you have to, the way it is set up, not even by me, it was set up. This is like a general setting like everybody else is using, all the professors are using. So the the textbook, I mean, the knowledge check, you have to pass by it. You have to do the knowledge check first. So now the knowledge check, look, something about the knowledge check is not about it's not about doing the questions right. No, the knowledge check, you can say, I don't know, I don't know, I don't know, I don't know. This has nothing to do with your grade, okay? It has nothing to do with your grade. Now, I don't see nothing here in my settings that prevent students after the knowledge check to use that. I don't see nothing here. Okay. So, but I can take a further look, right? Maybe write an email to the person who's taking care of it, stuff like that. But I don't see nothing here at my end that,
Right, that's just the message it gives me. I don't know if you actually did anything or not. That's
yeah.
just what it says when I try to access the textbook and haven't done the knowledge check yet.
So this is always, this happens every single time?
Yeah, every single time that there's a knowledge check and I want to access my textbook, it will say that and not let me access it until I do the knowledge check. So
Okay. You see, okay, the knowledge check now is a okay, initial knowledge check. Yeah, I think that that is how Alex it was set up. So it's not even me. It's how the objective stuff was set up. You know, it is like some type of generic thing, generic setting. So now the knowledge check now, it doesn't have to be. I have to have everything quite. Look, it does make sense. The knowledge check is: do I know something before even opening the book? That is a knowledge check. Do I know it before opening the book, before opening the calculator, before opening the notes? That is what you call the knowledge check. It does not count towards your grade. It is a check, right? So it does make sense to me not to give you access to the textbook because they want to know what you know at that moment, right? So that does make sense a little bit. Alex is the particular thing about Alex is those type of knowledge check. No, that they do. The other, maybe the other online stuff don't do it, right? They do it because they want to know what the students does know at this moment, etc., etc. So, all right. But I can take a further look, okay, after now.
Thanks.
Okay, so we're gonna try to do, I was saying we're gonna try to do some transformation of graphs, right? It is a section that will not have too much calculation. It's going to be just, if you have a graph, what type of transformation we can do on it? When do we go up, down, shift the graph to the right, to the left, etc., etc. Those type of basic transformation graphs. So now there's a section in 163 that is about the lines, right? I don't think we have to go over that section over and over because it's just a section, I will not ask about it on the test, etc. But it is, how to find the slope of the line, how to find the equation of a line. This is straight review from 082, 083, right? I mean, even not even 083, it's like 082, okay? I don't think, we have to take a lot of time to do, we have to take time to go over it. It's just a review section is going to take of our time. So you can read that, you can refresh your memories, how to find the slope of the line, how to find, the slope intercept form, how to find the slope point form, etc. You see. So we're gonna reserve that time for the new material. Okay, I think it's better for us. So let's start first by sharing my screen, and then that is transformation of graphs. That is transformation of graphs. Of graphs. And that is a section I see is 2.6, I think. So at first we're gonna see, when do we have to do the vertical shifting? Okay, so let's start with an example of two functions. I have f of x equal x squared, and I have g of x equals x squared plus 1. Okay, let me see for these two functions, xy, right? Let me graph these two graphs right here and see what's gonna happen. So we have 0, 1, 2, -1, -2. And here we have 0, 1, 2, -1, -2, right? So let me see what type of graph I get from these two right here. Okay, go ahead, fill up the two last columns, the two columns right here. All right, so okay, so Of course, right here, the one f of x equal x squared. How much is f of 0?
0.
0. F of 1 is
1.
1. F of 2 is
4.
4. F of negative 1 is how much?
1.
1. And f of negative 2 is
4.
4. So we got 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. That is F, right? Okay, now for G now. How much is F of 0? When you plug in 0 in G?
1.
You get 1. F of 1 is how much?
2.
2. F of 2 is?
5.
5. F of negative 1 is?
2.
2. And F of negative 2 is?
5.
5. Everybody agrees with that. So F of 0 is 1. F of 1 is 2. F of 2 is 5. F of negative 1 is 2. Right? F of negative 2 is 5. So we get this. Hold on, I'm sorry for the last 2 points were not right. Okay, F of 2 is 5 here, and F of negative 2 is negative 5 here. Okay, so excuse my, my graph is not like as precise as we like it to be, but look like right here. It does look like the green graph can be obtained by doing what to the black graph?
Shifting it up 1.
Shifting up 1 unit, right? The green graph can be obtained by shifting the black graph up 1 unit, right? You're going to see where the up come from and where the 1 come from. You see, so but if you look at all the points, every single point has moved 1 unit up. You see, 1 unit up, 1 unit up, 1 unit up, etc., right? So every single point has moved 1 unit up. So look now, how can we express G in terms of F? You see, G of X is X squared. What is X squared? Is it F of X? Is F of X plus 1, right? So what we have established is G of X happens to be F of X plus 1, right? What this example shows what? If you want a graph, if you have the graph of X, which is a black graph, and you want to graph a new function that is F of X plus 1, what you're going to do? If you don't want to repeat the same work, you just shift the black graph up 1 unit, right? The up comes from the plus here. This means up. And this is 1 unit. Okay? That is our first example. If you want to graph F of X plus C, you have to shift the graph of F upward 1 unit. Okay? So if C is positive, to graph Y equals F of X plus C, right? What we would do is we shift the graph of F upward C units, right? Okay. Of course, right here, we even don't need to prove it. Obviously, if you want to graph y equals f of x minus c, now what you're going to do then? Common sense, what you're going to do?
Shift it down C units.
Shift down C unit, right? Okay. When you do that, picture the domain and the range. Picture the domain and the range. When you do that, who is going to change? Probably. Who? The domain or the range? Or both? Who's going to change?
Both.
Both going to change? When you move something up or down, the x, does it change?
Just the range changes.
That's just the range could change, right? The domain does not change. You see, the domain is unchanged because when you move something up and down, the domain does not change at all. So domain does not change. And you see, if you move a point up or down, if you move a point, you have a point x, y. If you move it up, it becomes what? X. The y becomes what? You move it as c units, y becomes y plus c, right? If you have the point xy like this, and you move it down c units, right? The x doesn't change, the y becomes y minus c, right? The domain doesn't change, the range could change. What is the only instance of a range? When you move it up or you move it down, it doesn't change. When the range is what?
0.
I mean, the range is a set, is an interval, right? What is the only interval that does not change when you move it up or down? The range has to be what? So it doesn't change. It has to be. What is only stuff when you add something to it, it doesn't change?
Is it 0?
I mean, when you add 0 to something, it does change, right? What is 0 plus 10 is 10, right? So 0 changes. But what is the only thing when you add something to it, it is not sensitive to that. I don't want to say number because it's not a number.
Imaginary units?
No, I mean, something is like, you know, infinity. You see infinity?
Oh.
Infinity doesn't change when you add, you know, if you move something up 5 units and the range was like negative infinity, infinity. When you move it up, does it change? It's going to be still negative infinity, infinity, right? All right. Okay, that was just a parenthesis. But remember, that is our first transformation. Our first transformation is when do we move something up? When do we move a graph up or down? Is when you add or you subtract something to the y, right? Not the x, you see? The plus here, the plus is outside the parentheses, f of x plus c, or f of x minus c. Then you move up or you move down, right? So that is the first example, that's the first case. The second case will be, I mean, before we even move on right here, if I give you this right here, That is the graph of f. I want to ask you graph y equals f of x minus 3. Everybody go ahead, graph. This is what you know, the small tent you see here, this tent is the graph of f. Go ahead, graph this new one, y equals f of x minus 3. First of all, you have to say what you have to do to the graph before you even graph it. All right, so tell me, what is the transformation you need to do first?
Move it down 3.
Move it down 3. Everybody see that? So this means down 3. So how I do that? Every single point will move about 3 units down. You see this point right here moves 3 units down vertically, right? It comes here. This point right here moves 3 units down. 1, 2, 3, right? Comes here. And this one moves 3 units down. 1, 2, 3 comes here. So this is my new graph like this, right? And when you look at the domains are exactly the same, but the range did change, right? Okay. All right, so that is the first example. Now, the second example here is, the second case here is horizontal shifting. Horizontal shifting. Okay, we're gonna go about the same example, right? We're gonna go about the same quadratic because it shows really what we're doing. F of x equal to x squared again, right? And g of x equal to x minus 1 squared. Okay, so we're going to do the same stuff right here. Xy 0, 1, 2, 3, -1, right? And here we have xy 0, 1, 2, 3, -1, right? So we're going to do the two graphs right here, of course. All right, so right here, Of course, right here, f of 0 is 0, 1, 4, that is 9, that is 2, no 1. You see, 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4, etc. Right? Okay, go ahead. Now plug in the right table now. How much is f of 0 for the right table?
1.
F of 0 is 1, right? How much is f of 1?
0.
0, thank you. F of 2?
1.
1. F of 3?
4.
4. And f of negative 1?
4.
4. F of 0 is 1. F of 1 is 0. F of 2 is 1. F of 3 is 4. And f of negative 1 is 4. Now, everybody look now. What seemed to happen? How we seem to shift the black graph to red to get the blue graph? We seem to have shifted it how?
Shifted it to the right.
It seemed to be shifted to the right, right? So the black graph seems to be shifted to the right. About how many units?
1.
1 unit, right? So we're going to see where the 1 come from and where to right come from, okay? So the 1 unit looks like it comes from this one here. But look, now, can somebody tell me how we can express G in terms of F? Can you tell me that? What is the relationship between G of X and F of X? They're both squares, right? Can somebody tell me what is the relationship between G of X and F of X?
G of X would be f of x minus 1.
Oh, almost right. You said f of x minus 1. But look, f of x minus 1 is exactly what you have here. If you put minus here, right? But look right here. What expression here? What expression can we replace x by to get g of x? Exactly. We need to replace x by what? If I replace x with x minus 1, right? This x right here, if I replace it with x minus 1, what I get? I get x minus 1 squared, right? Do you agree? So if I give you f, if I ask you how much is f of x minus 1, what's everybody going to tell me? F of x minus is how much? You have to remove x and you put x minus 1. It's going to be x minus 1 all squared, right? Which is exactly g of x. So g of x is f of x minus 1, right? So what my example shows me? My example shows me if I want to graph f of parentheses x minus 1, do you see now the difference between f of x minus 1 and f of x minus 1? Everybody sees the difference? In the first instance, the minus 1 is outside. The minus 1 is about f of x. It's f of x and then minus 1. This is a vertical thing. In the second instance, the minus 1 is with the x. Where do we subtract the 1? We subtract 1 to the x, not to the f, right? That is a horizontal thing. That is about the domain, right? So what we're saying now, if you want to graph something like f of x minus 1, you have to shift your graph to the right. Now, isn't it a little bit surprising? Normally, we associate minus with what? What direction we associate minus with normally?
Negative.
Minus we associate with the left, right? Normally we associate minus with the left, but in this case, every time you see f of x minus a number, you have to shift your graph to the right, okay? You have to shift your graph to the right. If it is plus, you're going to shift it to the left. All right. So that is our second case. Our second case says to graph, if C is positive, right? If C is positive, it says to graph y equals f of x minus c, right? What you do here, shift right C unit. Right, okay? To graph y equals f of x plus c, you shift left C units. When you shift to the right or to the left, between the domain and the range, who could change? When you shift something to the right or to the left, between the domain and the range, who could change?
The X,
X will change. If the X changes, so who's going to change, the domain or the range?
domain.
The domain, right? When we shift a function, when we shift a graph to the right or to the left, the domain could change, though the range does not change at all, right? So if I have my point xy, if I shift it to the right C units, right? You see the x will become x plus c and the y doesn't change, right? And if I have xy and I shift it to the left C units, right? So the x becomes x minus c and the right doesn't change, okay? If c is positive. All right, so the domain could change, the range does not change at all. So what's going to be, for instance, not in this test, but in another one, or the quiz, the next quiz, or something like that, right? What you could see, you could see a very nice function like this, right? Okay, that is a very nice sum like that, right? That is my function right here. That is f. And we ask you to graph y equals, from this right here, we're going to ask you to graph y equals f of x plus 2 plus 1. You see, when you see this, how many transformations you think you're going to have to do? How many?
2.
2 transformations, right? When I see this, I see that I have to do 2 transformations, okay? The plus 2 here, what transformations the plus 2 will give me?
Shift to the left 2 units.
To the left 2 units, right? When I see this, this tells me I have to go left 2 units. When I see the plus 1, how I go? Outside, the plus 1 outside, how I go? You know, today I feel like I'm talking to myself, you know. I understand, you know, but I need—
Move up 1 unit.
Yeah, you know, I need, you know, some people to tell me, what to do. This is why 1 unit, right? So try to do that. So now, what do you think? Is it important what transformation we do first, or is that be the same thing at the end? What do you think?
I think it'll be the same.
I think it's going to be the same. I agree with you. Okay, try to do that. So now what I will advise you not to do it at once. Do 2 graphs. The first graph is to the left. The second graph is up, or vice versa, right? Try to do that. All right, so you see, it doesn't matter, what transformation we do first. It doesn't matter at all. So for instance, you can go ahead and go left. I hope that everybody is trying this problem at the same time you're saying. So you see, to do that, you have just to to say, okay, I have like 3 reference points, for instance. These are clear reference points. So I move each one of them 2 units to the left. 1, 2 units here, I get something like that, right? 1, 2 units, I get this one right here. 1, 2 units, I get this one right here, right? So what is my graph is going to be this and this, right? Okay, that is the left. And then up 1 unit. So I move everybody up 1 unit. So this one comes here, this one comes here, and this one comes here. So I get the same thing. So up 1 unit. Okay. So this makes it 4 transformations. When to go up, when to go down, when to go to the right, and when to go to the left. This makes it 4 transformations. We have some more to come, right? So we have some more transformations to come. Okay, now we're going to see what's called the reflections. You see, for instance, let us graph f of x, g of x equal to negative x squared, right? You see, we have a negative sign outside and we know f of x is equal to x squared. F of x is equal to x squared. So what we have this. We have this. So we have 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4, right? That is my F. Now let's do G now. Let's do G now. You have 0, 1, 2, -1, -2. How much is G of 0? G of 0 is
0.
0, right? How much is G of 1?
-1.
-1. Agreed. How much is G of 2?
-2.
Yeah, you have to score. You have to square 2, which is -4.
4. Sorry. Yeah.
-4, right? Okay, now look now. How much is G of -1?
1.
G of negative is 1, you think? The negative sign is outside the square, right?
Oh wait, it's -1. My bad.
Yes, you have to square and then apply the negative sign, right? It's going to be still -1. And G of -2 will be still -4, right? So when I graph these points, I get 0, 0. I get 1, -1. I get -1, -1. 2, -4. -2, -4, right? So I get this. What it does look like? What have we done to the black graph to get the blue graph? What transformation we did? What transformation we did to it?
Flipped it, mirrored it.
We reflected over what axis?
X.
Over the x-axis, right? And this is what's going to always happen. When you have a negative sign, if you want to graph the opposite of the function, you don't have to repeat the work. You just flip it over the x-axis, right? Okay, so that is our next to graph. To graph y equals negative f of x, say flip over the x-axis. You see, the x-axis is like the mirror, okay? Again, here, the domain doesn't change. The range definitely could change, right? But the domain does not change at all, okay? So what do you get? What is your guess? So we don't have to prove an example, but what is your guess? If you want to graph y equals f of negative x, what is your guess? How are we going to flip over what?
Y-axis.
Over the y-axis, right? We're going to flip over the y-axis. Okay. We're going to flip over the y-axis. So this example right here is not a good example for that case, you know, because the black graph has a symmetry, is completely symmetric with respect to the y-axis. So when you flip it over the y-axis, it's going to be the same thing, right? Okay. So far, to recapitulate so far, everybody, C is positive, right? What to do to get f of x plus c? What should we do? Don't look your notes, right? What we do here? F of x plus c. How we go?
Shift up C units.
Up, right? F of x minus c. How we go?
Down, C.
Down, right? F of x plus c, like this. How we go?
To the left, C.
To the left, right? F of x minus c. How we go? To the
Right.
to the right, right? Negative f of x, how we go? We flip it over what? Over the x-axis, right? And f of negative x, we flip it over the y-axis, right? This is y-axis. This is x-axis. All right. These are the 6 transformations so far. They are about addition, subtraction, and multiplying by -1, right? So we haven't seen yet what happens when you multiply a function by a number, or when we divide a function by a number, etc., etc. We haven't seen that yet. But these are the 6 first ones that are about that. So now, again, same tent, same tent here.
Sir, just let me see the recapitulate, please.
Okay, I'm sorry. Right? Okay. So if you do the
It's good.
same, if you do the same one right here, same tent like this. Can you graph y equals negative f of x minus 1 minus 2? First of all, how many transformations you have to do here?
2.
You see, every
Three.
time I see a minus or a plus, it is a transformation. So how many of them then?
3.
3 of them, right? We have to do 3. So go ahead, look at the recapitulative right here in red and say what is each transformation. Meanwhile, you can write your name for the attendance. All right. So from the recapitulative over there, right? From the recap. So this negative sign outside, what it does?
Flips it over the x-axis.
Exactly, flip over X. This negative sign here, what it does?
Makes it go to the right one.
Right one. And this negative sign, what it does?
It goes down 2.
Down 2. Thank you. You see? So, and then look, what do you think? Is there any order of operations here? Is there any order of operations here? Or can we do it, can we do them, you know, randomly? It's going to be the same answer. What do you think?
Don't you do left to right?
Left and right.
Or-
So, okay, so you suggest to for us to do the left, I mean the right, and then do the down. So what order? What order do you suggest for us to do?
Flip, then go right, and then go down.
Okay, look, that is very important. Thank you very much. Between flipping over the x-axis and going right or doing left, these are two independent movements, right? When you flip over the x-axis, what did you go? How did you go, vertically or horizontally? When you flip over the x-axis, you did go vertically or horizontally?
Vertically.
Vertically, right? When you go to the right or to the left, you went horizontally. So they don't have no interaction. So these two, you can do them in an order you want, right? But the flipping over the x-axis and the going down, right? Which one has to be done first? They're both vertical, right? Which one had to be done first?
Flipping.
The flipping. Thank you. If you go down and then you flip, that means the flipping will affect the going down, right? But as we can see here, the flipping should not affect the going down, right? Okay, the going down is after you're done flipping, you have to go down 2 units, right? After you're done flipping. So that is the only requirement here. The flipping and the going down, you know, they have to be done in a certain order, but everything else, you know, is good. So we go right 1 unit, you see, this one goes here, this one goes here, this one goes here. So this is right 1 unit, okay? And then we flip over the x-axis, which means the x-axis is a mirror. This one does not move. This one was 2 units up, it's gonna go 2 units down. This one doesn't move. So this is the flipping over the x-axis. And then go down 2. Now everybody goes down 2, so this one comes here. This one comes here, and this one comes here. And this one is my final graph, okay? So the red one is right 2. The blue one is flip over x-axis. And then this one is down 2. I mean, it's right 1, I'm sorry. All right. So these are the 6 transformations that are the first ones. You know, 4 of them are about plus minus, and the 2 of them are the reflections when you multiply by a -1, right? But now here, what you're going to do is what happens when you multiply a function by a number? What happens? You see, look right here, all the transformations we did, all the graph, look at what is something that didn't change all along. What is something that didn't change about the graph? The
X.
The X, you know, I mean, in this case, you know, X has moved, Y has moved, but something remains the same, is the size of the graph. You see, the graph didn't become larger or smaller. It is the same size. Do you agree with me? Look at all the colors here, the black graph, the red one, the blue one, the green one. The size is the same, right? I didn't get a bigger graph or a smaller graph. I got the same graph, I just moved it. I just moved the graph, you know, here, 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 etc. But what can happen here when you multiply by a number, the size will change, you see? The size will change either vertically or either horizontally. It's gonna shrink or it's gonna stretch, right? That's gonna happen when you multiply by a number. It's gonna shrink or it's gonna stretch. So, and that is, our next example is vertical stretching / shrinking. So basically, stretch or shrink the range. When do we stretch or when do we shrink the range, right? Let's see an example right here. That is my f like this. That is f, right? Okay, so look, I have a new function, g of x is 2 times f of x. Okay, g of x is 2 multiplied by of x, right? Okay, look, how much is f of 0? What's the graph tells you? How much is f of 0? What is f of 0 from the graph? F of 0 is, I mean, I know, somebody has to answer this question. How much is f of 0?
2.
From the graph right here, no, from this blue graph, f of 0 is 2, right? Thank you very much. How much is f of negative 3? From the graph.
0.
F of negative 3 is 0, right? Thank you. F of negative 1 appears to be 1, right? F of 2 appears to be 1 also, right? Etc. And f of 3 appears to be 0, something like that, okay? So that is my graph. Now, look, now let me do the g's now. Using the definition of g, what's going to be g of 0? By definition is 2 multiplied by f of 0, right? If I do that, g of a number is 2 times f of the same number, right? So g of 0 is 2 times f of 0, which is 2 times 2. Everybody agree with that? That is 2. It's going to be 2 times 2, which is 4. So g of 0 is 4. What is g of negative 3? Is 2 times f of negative 3, which is 2 times 0, which is 0, right? What is g of negative 1? Is 2 times f of negative 1, which is 2 times 1, which is 2, right? So g of negative 1 is 2, right here. What is g of 2? Is 2 times f of 2, which is 2 times 1, which is 2, right? G of 2 is 2. And g of 3 is 2 times f of 3, which is 2 times 0, which is 0, right? So what is my new graph? My new graph looks like this. Now look, compare the two graphs now. Are they of the same size? You see, now the size has changed, right? The red graph appears to be stretched how? It appears to be stretched vertically, right? The range has changed, right? What is the old range? What was the old range? The old range was from what y to what y? The blue graph. What is the range from what y to what y?
The old range was from 0 to 2.
0 to 2. Thank you. What is the new range? What is the range of the what is the range of the red graph? From what y to what y?
0 to 4.
0 to 4. As you can see, the range has doubled, right? And where's the double come from? Where's the 2 come from? The 2 come from this right here. Okay? When you multiply a function by 2, you stretch the range as many times as the number, right? If you multiply by 5, you're going to stretch it 5 times. If you multiply by 6, you're going to stretch it 6 times, right? Okay? If you multiply by 0.5, what's going to happen? Does it stretch? If when you multiply a number by when you multiply any number by 0.5, right? You get a bigger number or a smaller number?
Smaller.
Smaller number, right? When you multiply by a fraction, your graph will stretch, you see? All right? So that is what happens. So that is a new case. So to graph, if A is positive, to graph y equals AF of x, what you do, we have 2 cases. If A is greater than 1, stretch the range. A times. Okay? If A is less than 1, shrink the range. Okay? So when you multiply by a number outside, you see now who is multiplied by A is not x, is f of x, right? It's not x who is multiplied by A, is f of x, right? So for instance, if I want to do this, if I want to graph what do you think we're going to do to the graph? What do you think? Will we stretch or shrink the range? What do you think?
Shrink.
We're going to shrink the range, right? 3 times, okay? If you have y equal 1/3 f of x, you're going to shrink the range. How many times? 3 times. Okay, if you have y equals 7 f of x, what you going to do to the range?
Stretch it.
Stretch it
I guess 7.
7 times, right? And when you do that,
If it's a fraction or not?
huh?
Does it matter if it's a fraction or not?
I mean, it does. A fraction means what? It does matter if it is a fraction. It does matter if the number in front is less than 1, right?
Right.
That does matter.
Okay.
So the comparative is 1. If the number is bigger than 1, the range will stretch, right? You see, if the number is, even if it's like, you know, 1.3, even if it's 1.3 f of x, what's going to happen to the range? The range will stretch, right? But if it is a number less than 1, like, you know, 0 point something, 0 0.1, 0 0.2, 0 0.75, etc., the range will shrink, okay?
All right, thank you.
You see right here, so now, what do you think? If I say y equals, list all the transformations. I'm not asking you to graph them, but just to list them. If you have y equals negative 1/5 f of x plus 3 minus 6. What are all the transformations you think?
Shrink shrink the range by 5. Then shift
Shrink
to
the
the
range by
right.
5. I agree with that, right? So a question here. Is it easier to consider the number in front, negative 1/5, as one transformation or two transformations? What is easier?
2.
Two transformations, exactly. You see, the 1/5 by itself and the negative sign by itself, right? So you were saying, Sharif, so you have to shrink the range by 5, right? Okay, I agree with that. Shrink the range by 5 because of the 1/5. And then the negative sign in front of the 1/5, what you gonna do?
Flip it.
Flip it over
Yeah, flip it over the x-axis.
the x-axis, right? I agree with you. The +3, x plus 3 inside, watch how you go.
Shift to the left 3
You go to the
units.
left 3 units, d'accord. And the -6, how you go?
Shift down 6 units.
6 down 6 units. You see, you have 4 transformations, right? Of course, in a test, you know, will I bother you with 4 transformations in a test? Of course not, right? In a test, you know, probably 2 transformations, 3 at the most, right? Okay, but this is this section right here. We haven't done no, and it is almost time, and we haven't done no calculation whatsoever, right? 0 calculation. This section is a note section. 2 months from now, when comes the final exam, you have to remember all the cases, right? If you want to be able to do that. That is a note section, okay? We haven't done no math in it, you know, we didn't do no plus, no minus, no, you know, it's just a note section, okay? So of course here, what is left for us to do is, the last stuff, how we shrink or we stretch horizontally, shrinking, horizontal, shrinking or stretching. It is shrinking or stretching the domain, shrink or stretch the domain. And this one, we're gonna do it after, next week after the test, okay? So this is not included in the test. So everybody, so like I said, the topics that's gonna be on the test, they are in the review sheet, right? That gives you the topics. Now, feel free to practice more problems, right? Okay, this is test number 1. I think everybody should take advantage of it, right? Because the material, half of it, almost all of it is like review, okay? The whole chapter 1 is like a review. I think everybody should take advantage of the test number 1, all right? Because no telling how it's gonna be test number 2, you know, when the topics are different, okay? So prepare and don't miss a test, please do not miss a test, because after the fact, when somebody misses a test, they have 0, okay?
When,
And yes.
sorry, I have a question.
yes,
Is the test going to be in class or are we taking it on our own time?
yeah, no, it's gonna be it's gonna be like, a Zoom session, for instance, Tuesday at 12:30, 12:45, right? You're gonna have access to the test while in the Zoom session. Everybody gonna have the camera on. I have to watch, right? It has to be proctored, okay? The test has to be proctored. So everybody, you have to have a camera, and you're gonna try to fix your camera on your paper, right? Okay, do the best so I can see the work, because the face, when I look at the face, I cannot see what happened, I really cannot see what happened. Somebody, I mean, I know everybody's a good face, right? But, we have to do that, okay? We have to proctor, all right?
So are you gonna post the questions on your screen?
No, it's gonna be, you're gonna have access, you're gonna go to Brightspace and you're gonna open the file, okay? But it's gonna be only available to you at that time. For those people who go to the testing center, they won't be able to access through Brightspace. I mean, they will be able to access that, so they have to go to the testing center to have that. But hold on. All of you, you have, when you come 12:45, when I say go, you will have access to the test. You open the file, you're gonna see the file on your screen, and then you take a loose paper where if you have a printer at home, you can print it out. If you don't have a printer, you take a loose paper, and then you do the answers. Yes.
Okay. So I have a question about how we are grading our assignments in ALEKS. So like for our, the assignments you have us do, are you taking like the average of all of the percentages that we get on these things, or are you just like tacking it on as like one
Yeah,
grade?
that is a good question. Basically, I have no input how to about the grading. ALEKS does it automatically. But everything you do, ALEKS take into account everything you do correct, right? I think internally it even have like some type of, partial credit stuff, but everything is done automatically. So when I go to ALEKS, I just pull up the grades, okay? So, and this is based on the objective, what they call objective. So when you complete exotic or you complete, part of it, nothing is lost, no work is lost. ALEKS grade is like, it's fairly graded by ALEKS inside, okay? But me, I just go ahead and pull up the grades, okay?
Yeah,
but
I have a question.
For the test, I'm the one who's gonna grade the test, yes?
Do you know how many questions the test will be?
Yeah, I mean, probably like 13, 14. See,
Okay.
I don't want to make it like 10 questions, because 10 questions, is they're all evenly weighted. If you miss one question, you cannot have an A anymore, right?
Yeah.
So it has to be like 14 questions, something like that. So you will have time. It is a 1 hour test. So the 10 more minutes or 15 more minutes to allow people, or I mean 10 more minutes to allow people to scan the paper, and then to submit it on Brightspace or to send it to me. The best way to submit on Brightspace, just like you did quiz number 1, I think everybody was able to get a PDF file. That is very helpful to me. If you got a PDF file, right? That is very, very helpful to me. Now, if you're struggling to get a PDF file to submit it, last resort, very last resort, you can take a picture and send it to my email, right? But it's going to be done on Zoom. It's going to be done while I'm watching, right?
I'm gonna have to send it to you through email because my computer has issues converting things to PDFs.
Yeah, okay. So if you send it to me, and everybody you send the file, you wait like a couple of minutes until I tell you I received your file, okay? And then you can log out. Okay, so see you Tuesday for the test, And like I said, everybody try to get a very, very good grade on this test because you can do it, okay? All right, everybody.
See you Tuesday. Have a great weekend, everyone.
Have a great weekend, everybody. Thank you.
Thank you.
Thanks.
Thank you.